Find all real and imaginary roots of the polynomial equation x cubed minus 5x squared plus 9x minus 5. So I'll begin by writing down our equation. X cubed minus 5x squared plus 9x minus 5 is equal to 0. And we have 4 terms here, but this polynomial equation will not factor by grouping. So I want to use something called the rational root theorem. And what it says, in a nutshell, is that if I would look at all factors of the constant over each of the factors of the leading coefficient, this will tell me all possible rational zeros for this polynomial equation. Now, in this particular example, our leading coefficient is 1. That is, the coefficient in front of the x cubed is 1. So I'm going to consider the constant. And the constant is 5. So if I take all factors of 5, which are 1 and 5, as well as the plus or minus of each of those factors, which is equivalent to plus or minus 1 plus or minus 5, this represents all possible rational roots for the polynomial equation. Now, if something is a root, if a number is a root or a 0, then if I use synthetic division, I should find that my remainder is 0. So I'm going to go ahead and just start with 1, positive 1. So in using synthetic division, I'm going to put a small box here and put in my possible root or possible 0 of 1. The next thing that I'd like to do is to write down the coefficients of the polynomial. And so that is 1, negative 5, 9, negative 5. Also noticing I'm not missing any terms here. I have the x cubed, x squared, x, or x to the first, as well as the constant. So I'm going to write down those coefficients. So that was 1, negative 5, 9, negative 5. And I'm going to do the process of synthetic division. So I'm going to bring down this first number, which is 1, and then I'm going to multiply to what's up in that small box up here. So 1 multiplied by 1 is 1, and I'll put it here. Now I'm going to add up these two numbers. So negative 5 and 1 is negative 4, and I'm going to multiply to what's up in this small box in the left. So that is negative 4 times 1, which gives us negative 4, and I'll put it here. Next, I'll add the 9 and the negative 4, which gives us 5, and now I'll multiply again to what's in that small box. That gives us 5. Add the negative 5 and 5, and I have a 0. This last number tells me that I have a remainder of 0. And since I have a remainder of 0, then that means this value of 1 is one of the roots, or one of the zeros. So now, I'd like to know what's left over after I've done this synthetic division. I started off with a degree 3 polynomial. These numbers, 1, negative 4, and 5, represent the coefficients of the remaining polynomial. So since I started off with a degree 3 polynomial, I'm going to decrease the degree by 1, or the exponent by 1, and this corresponds to the x squared, so it would be 1x squared. This corresponds to the x term, and this corresponds to the constant. So right now, I know that one of the zeros, one of the roots, is 1, and I need to find the remaining roots. So I'm going to use this polynomial. 1x squared minus 4x plus 5. So let's take a look at that. So we have x squared minus 4x plus 5 is equal to 0. This is a quadratic equation, but it will not factor. So I'm going to use the quadratic formula. So the quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2 times a. So substituting in the a, b, and c where appropriate. This is the opposite of b. Let me go ahead and state what a, b, and c are over here to the right. So a is equal to 1, b is equal to -4, and c is equal to 5. So I'll use these values and plug them into the quadratic formula. So we have the opposite of b. The opposite of -4 is 4, plus or minus the square root, or the square root of b squared. So for b squared, I have -4 squared. -4 times -4 would be a 16 minus 4 times our a, which is 1, times our c, which is 5. All of that over 2 times a. And again, a is 1. So I'll continue working in this direction. So we have 4 plus or minus the square root of 16 minus 4 multiplied by 1 multiplied by 5, which is 20, all over 2 times 1. Now continuing to simplify, we have 4 plus or minus the square root of 16 minus 20, and that is -4, all over 2. Simplifying a little bit further, we have 4 plus or minus the square root of -4. The square root of a negative is I. The square root of 4 is 2, so 2i, all over 2. And the final simplification, I'll divide both 4 and 2 by this denominator of 2 to get 2 plus or minus I. 2 goes into 4 twice. 2 goes into 2 once. It's not necessary to write the 1. I can just write it as I. So the additional 2 roots are 2 plus or minus I. This represents 2 plus I as well as 2 minus I. And so for the polynomial equation, x cubed minus 5x squared plus 9x minus 5 is equal to 0, we found all real and imaginary roots.